Hello, everyone. Thank you for joining us at our Building Smart USA webinar series. Today, we have Scott from HNTB, who will be giving us an update to a presentation that he gave us last year in Chicago, if some of you have joined. If not, we have a recording that we can refer you to. But this is an update to last year's Demystifying openBIM for Highway and Bridge Practitioners. We'll let Scott get started and enjoy the webinar. So Q&A is open. Feel free to enter your questions in there. We'll get to them at the end of the session.
Hey,
Scott?
thank you, Janice. Yeah, as Janice had mentioned, this is a bit of a follow-up to a presentation I had done last summer, and there is a recording available. So if you were with us in person or if you have watched the recording, thank you for that. So we'll revisit some of those same concepts and same discussions for maybe people that haven't seen that before. And so that's why we're calling this part 2, but also with a subtitle of Seeing is Believing. So I'll have some additional examples and we'll talk through some real projects and examples where some of these openBIM principles and workflows and processes are actually being deployed. So to give a little bit of an update on me as the speaker. So as Janice mentioned, I'm with HNTB. I'm a senior VDC specialist there in our digital transformation group. My background is in civil engineering. I'm a registered professional engineer here in Indiana. So we can kind of tell my story in these 2 pictures here on the screen. So on the left, this is the first project that I was ever involved with in industry, actually 25 years ago this summer as a lowly summer intern. And this is in Indianapolis on the southeast side. So I'm lucky enough to actually drive through this project on a regular basis. So after following this summer and a couple more summers on grade, and then after completing my degree, my first 15 or so years in industry were fairly typical plan specs and estimates, project development and design for highway and bridge projects. Similar to this, a lot of interchange added capacity and interchange reconfigurations. And now, say in the last 6 or 7 years, have pivoted more towards the technology side. So working with a lot of our teams and our clients around BIM for bridges and structures, as well as BIM for infrastructure. I like to say that I've tried to learn as much as possible from our experienced folks that have done BIM in the vertical industry for buildings and facilities and wastewater treatment plants, and now work to apply some of those best practices and lessons learned to the infrastructure domain. So then on the right-hand side here, this is some of my life outside of work. Obviously, I spend a lot of time with family. And then my main hobby sort of outside of work is playing music. So this is a picture of our stage from earlier this spring. So we were in the path of totality of the solar eclipse. So this is a picture of the stage during the eclipse. And this actually is looking to the north. And so you can see it looks kind of like a sunset, but obviously the sun doesn't set in the north. So this was during that period of totality. Okay, so to talk about demystifying, we'll look at the definition here of mystify, so as a verb. And my task today is to demystify openBIM, right? That it shouldn't be mysterious or obscure. And the approach will be to take various concepts from openBIM and relate them to common tools of the trade, things that most highway and bridge designers would be familiar with. And today my focus will be primarily on design and project delivery phase of the asset lifecycle. Not because openBIM doesn't apply to the other phases, but it's the sort of the time in the life cycle that I have the most experience with. And so speaking to that primarily from experience and making some of these connections. So to focus on a little bit of definitions and foundational concepts, when we're talking about BIM, I like to use building information modeling as a verb and then usually BIM model as the noun to refer to the actual 3D model. And we like to say that there's two main components to parametric BIM modeling. That you have the parametric geometry. In this case, we've got some ability to adjust the substructure placement and some of the dimensions and constraints and whatnot. So we have parametric geometry as the primary component, and then metadata or property sets as the secondary component. And these two work together to build the information model and help with the information exchanges during development of a design project, and then flow through into construction and into operations and maintenance, and ultimately then circle back to maybe potential planning and environmental work as well. Okay, so a few openBIM principles. I'll kind of step through this quickly, but essentially, I like to think of it as primarily a collaboration process, and it's vendor neutral. So it allows folks to work in the environments that they're most comfortable with, and provides you the ability to work in the best tool for the job, and not necessarily have that dictated based on potentially external factors like where your data is being hosted. In terms of openness, the open part of BIM, this means can mean multiple things, right? So primarily, in my view, this means a published specification that's open, that can be used for developing and sharing and understanding the exchange of engineering data. But it can also mean open as in it's easy for you to open it and take a look at it. So, for example, here we have an example IFC model in the most common file format, the plain text step physical file. And so you can actually open it up in something like Notepad or VS Code and take a look at it. Now that may not be the way that most people interact with IFC, but it is a potential. Because of this openness and because of it being openly documented and tested, then that adds reliability to the process. And I had mentioned collaboration, right? That we aren't, everybody gets a seat at the table, regardless of their particular tools or workflows that they like to bring. And then, flexibility as well. And ultimately, then there's also the concept of sustainability, right? That over time in the long haul, that data that's stored within these formats and to these specifications then allows for them to continue to be accessed over time, over the long haul of multiple decades, right? Which is oftentimes the time frame that we're talking about with infrastructure assets that have a design life of potentially 100 years or more. So I'm going to maybe hone in on a couple of things that speak to me in particular. So interoperability and flexibility. And so when we're talking about openBIM as part of contractual language or as part of a contractual requirement on a project, we're primarily talking about a data specification, and we're not talking about means and methods. So to do kind of a compare and contrast with sometimes what you see in the design in terms of standards and compared to what we do during construction. So you think about if you were reading a construction specification specifically around common excavation. Well, one of the things that you wouldn't see is a restriction on the brand of equipment that a contractor is able to use, right? Because that would be very much dictating means and methods, right? So just kind of as a example here of what you wouldn't see, right? A spec that says particular brand of equipment isn't allowed here, right? And so, this is better. So I guess the point here is that you wouldn't see this in construction, and so it begs the question of why we see that sometimes in design during the development and procurement phase of our projects. Okay, so what I see is kind of the foundation of openBIM, industry foundation classes or IFC. So this is as I mentioned, kind of the the main specification for the data that we're talking about with openBIM. Again, standardized, digital, open, and international in scope, and has multiple use cases. And one of the things that I'll mention a couple of times here, and we'll get into in a little bit more detail later in the presentation, is not to think of IFC as a file format, but rather to think of it as a specification for the data. And just as an example here is some proposed storm sewer from a project that we have been involved with over the last couple of years, and demonstrating that flexibility, right? So this is a system that was originally designed and authored in Civil 3D, and then it's able to be reviewed in an online viewer here, like we see on the right, but could also be pulled into a completely different desktop application, like we see here on the left with the Blender BIM add-on for the open source Blender modeling environment. Okay, so I mentioned as part of the demystifying approach that I was going to draw some connections between openBIM concepts and generally familiar concepts in industry. So the first connection here that we'll make is between IFC and DXF. And so I would probably wager that it's a safe bet that most people in industry in our line of work have come across DXF files at one point or another. It's in some ways it's kind of the lowest common denominator, again, that allows for exchange of drawing information. So a couple of similarities here that I see between DXF and IFC is that there's a strong support and a lot of focus on geometry, as well as being able to segment information into various layers that allows for presentation, breakup by presentation, being able to turn certain things on or off, also driving the display of various elements in terms of, say, color and line weight and line style. And also, I think maybe primarily that multiple tools can read and write this format. And so it, as I mentioned, it becomes a way, at least one rudimentary way to exchange information between systems. So then some differences here, at least on the DXF side, is that it really is geometry only. There, you don't have the kind of the second part of BIM that I had shown previously, the metadata and the property sets. And this is an example too, where the DXF format is controlled and defined by a single vendor. So again, not having the same level of openness and international standardization as IFC. All right, so moving along, another connection that we can draw is between IFC and a points file, an ASCII points file. And at least in my experience, this is most commonly seen in the collection of survey data. So the surveyors and surveying technicians will be out in the field and make their various measurements to collect the data, then process it and adjust it and calibrate it, and then typically will be delivered in text format, similar to this, either with spaces or potentially commas. And so we've got, again, some similarities here that we'll draw between IFC and our venerable ASCII points file, right? So it's similar that these, the points data, like we're seeing here, is vendor neutral, and it's plain text, right? So you can open it in Notepad or another similar type of editor. But some differences here in terms of the points file is that there's really no schema defined here, right? So it's usually it usually isn't any information in the header at the top. So you sort of rely on just typical practices of the data normally being formatted, like with a point number and then northing, easting, elevation, and description. So that can lead to some ambiguities, right? That if some of those columns are switched for whatever reason, then you can have some issues being able to effectively share that information and exchange it between systems. And then also, I think crucially, a big difference here is that the process for doing quality control on points files can be very manual, right? It typically involves opening up your authoring platform and importing this information and doing some visual review. And so oftentimes that can be a bottleneck for the receiving party, that there's some effort there to review the data during the exchange before it's brought forth into the next system and the next step in the process. So kind of taking the next evolutionary step is drawing some similarities between IFC and LandXML. So from my perspective, at least looking back kind of on my career, I think LandXML is maybe the closest thing that we have had historically to openBIM being widely used in the industry. And in fact, we see this now currently with a lot of digital delivery and digital deliverables from infrastructure projects that oftentimes alignment data and surface data will be exchanged via LandXML. Potentially even some other items, survey points maybe, or drainage networks and so on. So again, some similarities here, really across all of these things that we're talking about. It's vendor neutral. It's plain text that you can open up and review and look at. But some differences here with LandXML. Again, it's not standardized at the international level. And in the case of LandXML in particular, is little to no active development or active work continuing to progress this. And so not the same level of efforts and collaboration that we see in terms of the IFC standard. Okay, so next in terms of openBIM concepts that I want to talk through is BIM collaboration format, or BCF. So this is an open standard for communication to identify and exchange model-based issues. I like to think of this as issue tracking that's integrated with model geometry as well as plan sheets. So you can see in this particular example, this software utilizing information exchanges through BCF and flagging an issue here where there seems to be some inconsistency between a 2D plan sheet, a location of the column in a 2D sheet compared to where it's currently showing in the model. So the connection that we like to draw here is to compare BCF to what I would call the venerable issue tracking spreadsheet. And again, this is fairly common across our industry. And so some similarities here is that in both cases, we're talking about a list of issues with status and assignments, and it's used for collaboration and review. Some differences here with our spreadsheet is that it's really text only. It's not graphically tied to plans or any specific elements or objects in our BIM model. And the specific format and layout will vary and can get potentially could get broken by the end user, right? If someone's not careful about adjusting columns or adding columns or whatnot. So this is a good point that I'd like to kind of make a little bit of a step back and talk about some more recent developments, at least within our organization at HNTB. Within our quality management process, we have standardized forms for record keeping for these various quality control steps. And we can see here on this slide a similar example of what we were looking at before, right? A comment resolution form. And what we are currently progressing towards is as we move more and more into digital delivery and work through the application of our quality management systems and quality management processes to digital delivery and model first development, we see a really great opportunity to be efficient across the board by standardizing on openBIM formats like BCF in particular. And so what this allows us to do is to utilize the same process and the same data formats for this part of the quality process, really across the board, across all of our projects, right? So regardless of the software tools that are being used for authoring the models, and any tooling or systems that are being used for collaboration and um, review checking, similar that we had talked about. As long as these systems support BCF, then that allows us to get to a common point where we can aggregate all of that information and then report it in the same format that all of our designers and practitioners and project managers are used to and familiar with, and provides the same quality record across the board. So this is really valuable to us and promising to us, because it means that we can um, develop this workflow once and then apply it essentially universally across all of our projects. Again, regardless of what specific software tools are in use on any given project. Okay, so moving along in openBIM terminology to information delivery specification, or IDS. So this is a machine readable specification to exchange or to define the requirements for an exchange in an information exchange. And IDS is much newer than IFC. The initial version 1.0 has now reached final status. And I believe this has happened pretty recently, maybe just in the last month or so. Some examples here of what we have started to use IDS for. This particular example that I'll talk through comes from a project where we're doing a significant amount of subsurface utility engineering and modeling as well. So anyone familiar with that type of work, you've probably heard of the quality level designation. And this is part of multiple standards that are documented by ASCII, amongst others. But the quality level sort of refers to the ability of a downstream user to be able to rely on the information that is modeled or provided as part of those model elements, right? And so because these items are underground, it's hard to access them. And if it's something that's maybe been in place for multiple decades, then it's common that it's hard to find the records of what was actually built, what materials, how deep they are, location, all of that sort of information. So our digital governance requirements for this project require that all of the model geometry be attributed with certain property sets. And one of those requirements is that all of the model elements have a property set that's called utility, that contains a property called SUE, S-U-E, for subsurface utility engineering. And the values need to be either A, B, C, or D. So here on this side, we see one example of a potential web-based interface for building out those specifications. And then you can see in this example, there's an option to download the IDS file. And so then when you do that, that's where you get the machine readable file that can then be used for various systems. And the great thing here from my perspective is that you can run these at scale in batch mode for checking model data. So in this example, this IDS spec runs against a model that has 5,000 or more elements, and it processes through in a matter of 2 to 3 seconds. And then this is an example of some of the output that we get. So on this project, we're using Civil 3D as our authoring platform. And we've built out this report with some columns of interest, essentially to help the modeling folks track down the specific objects that need to, in this case, need to have this property set added. So this is giving a list of non-conforming elements that don't have that property set. And so then this report then is a nice way we could put that in a Bluebeam session and utilize our normal color coding and checking process to confirm that all of these items have been addressed before the next deliverable. And this that the item that I wanted to note here is that we have a custom column here for the handle of these elements. And that's a unique identifier within our DWG model that allows our modeling staff and technical staff to be able to track down these items in the authoring platform and make those changes. And then that unique identifier also shows up in our model coordination and collaboration platform as well. So just in terms of order of magnitude of people that are working through or working in these various systems, we have around 10 to 12 folks that are involved in authoring the utility models. And then there's maybe 200 to 300 users in the model collaboration platform. And the majority of those are not what you would call heavy duty users of CAD and BIM software, but they're able to get in and see the geometry and then review property sets as well. So the connection here is to be drawn from openBIM to common concepts is that the information delivery specification is similar to a QC checklist that you've seen before, right? So similarities in terms of their purpose in the contract, the ability to be customized for a specific project or client or project type, and again, essentially defining the information that needs to be checked and confirmed as part of an information exchange. So then some differences here in terms of the QC checklist approach, that it's a manual checking approach and can take a lot of time because of that, as compared to what I had said in the example with checking the utility networks, of being able to check thousands of objects in a matter of seconds. The other item that is a little bit unique that I'll talk about a little bit more here is integration with the Building Smart Data Dictionary, or BSDD. And so the data dictionary is a standardized way of publishing these information requirements that IDS can then check against, right? So if we think back to the example where we were defining the specification for quality level, we had to manually list that, or we had to specify the name of the property set and then the name of the specific property, and then list those 4 values that would be considered valid for that particular specification. So all of those types of requirements can be stored in a data dictionary, and then it's online and it's in a single spot. And so then that data dictionary can spell out all the requirements for an information exchange. And in our current discussions and work that we're doing with the transportation agencies in particular, we're talking through what that looks like with things like pay item information. So an agency could publish the pay item names and numbers and units as part of a data dictionary. And then you could utilize IDS to check models against those requirements as part of quality control during an information exchange. And then there's also a similar parallel here for us at the organizational level, utilizing IDS, again, as part of our quality management system, and being able to standardize on that in the spirit of openBIM, and providing the flexibility of having one process, one tool chain, so to speak, that handles model checking for us across all of our projects, again, regardless of the specific software tools that are being used on the project. Okay, and so then the sixth connection here that I'd like to make is between IFC and PDF files. So in terms of similarities, PDF is certainly, I would say, the de facto way of currently delivering our construction plans. I think it's safe to say that most users and owners feel comfortable with PDF as a long-term archive. PDF and IFC are both open published ISO standards, meaning multiple tools can read and write. And I think in some ways you can think, or you can think of this in terms of PDF is to 2D what IFC is to 3D. Again, because of some of these similarities here, and that's why I see that's why we see the interest in IFC and open data standards as a foundation, eventual foundation as for digital delivery in infrastructure projects. So lots of benefits here in terms of the similarities. Some differences when we're looking at PDF compared to IFC in particular is that essentially we're just operating within the sheet coordinates, and PDF at its core is really more about a set of instructions for painting a picture on the screen, more so than actual geometric data. And in the case of PDF, you may have property information that's part of the sheet, but it's not necessarily associated to its corresponding geometry. And again, a familiar refrain here is the lengthy process of QC of PDF sheets compared to some of the things that we can do with IFC around, in particular, IDS and Building Smart Data Dictionaries. Okay, so we'll kind of shift into part two here and cover some additional new ground compared to the presentation from last year. So I want to talk about model validation, and then also talk through some examples of openBIM in action for digital as-builts. So first, in terms of model validation. So I've mentioned this a couple of times in terms of thinking of IFC as a schema and not a file format. And technically, there are even multiple valid file formats for IFC exchange. The most common is the step physical file .ifc. But there's also a zipped version of that as well that could be utilized, or XML-based versions of or XML file formats for IFC exchanges, as well as RDF and TTL for more semantic web modeling of the information. But when we're talking about model validation, again, we're thinking of it as a schema, and a good way to think of schema is a specification for your data. And essentially, this boils down to a pass-fail test, right? So you're looking at the data in a model and determining, is this valid? Is it in accordance with the specification for the data or not? And so the reason this is important is that as openBIM continues to gain ground, at least here in the US, we see more and more owners gravitating towards a shared data approach, right? So you'll talk about agencies that have multiple different systems for information management across all of the things that they do on a day-to-day basis, potentially even hundreds of various systems. And a lot of times these are siloed from each other, that it's hard to move information from system to system or to share those types of things. But if you think about what the agencies are doing, there's a lot of overlap in this data. And that then leads to this desire for interoperability around all of these systems. And so this graphic is from some recent research at Purdue University. But again, kind of laying the foundation for lifecycle integration of IFC data, BIM data, as a central repository that then allows multiple different systems to pull and to read and write from, right? So again, you've got overlapping informational needs across a number of different systems, but then you also have specific niches or specific valid workflows and viewing types of applications depending on the users and depending on where you are in the asset lifecycle. So for this concept to work, as you suspect, you really need to have some robust policies in place in terms of data governance of what is in this central model, what's accepted in this central model, and then also need some heavy-duty validation capabilities, right? The old adage of garbage in is garbage out. So this leads us to our next connection in terms of this schema and relating it to construction specifications, right? So again, both of these concepts are playing kind of the same purpose in project delivery, and they're both relatively formal published standards. But again, common differences that we can see, at least in interpretation and enforcement of construction specifications, is that it's a manual effort and sometimes can take a lot of time, particularly when there's a disagreement maybe between parties on whether or not the construction specification has actually been met. And then also, again, at least for transportation work, a lot of times the majority of these construction specifications are fairly narrow in scope geographically, so a local scope maybe at the state level, as opposed to the global scope of the IFC data specification. So one of the tools that Building Smart International has developed and provided is a validation service. I've got a link here to the website that describes this, but essentially it's a free online platform for validating IFC files and models developed by Building Smart with the help of software vendors. So given an IFC file, the validation service provides a judgment of, again, kind of coming back to the pass-fail, right? Does this model comply with the specification? Does it implement the specification correctly or not? And you can see there's multiple things that are being checked here in terms of like kind of at the low level of the syntax of the file, right? Is it able to be read correctly? Moving into the schema, and then additional levels of rules, and then can also do a judgment of compliance with BSDD when there is information in a model. And then there are a lot of other things that aren't being checked. So because this is the validation service is international in scope, then it doesn't check anything project specific or national specific or organization. And so that at that level, that's where other items like IDS can really come into play. So we've got a little bit of a demonstration here. We can play a video of looking at the validation service in action here. So the data that I'm using is alignment data from a project that we were involved with last year. And I will caveat that this data has been around for a little more than a year. I think 14 or 15 months now from when it was originally generated. And so you'll see this come up with some red icons here, indicating that these files are not valid in accordance with the finalized IFC 4x3 Addendum 2 that was the published final standard. And again, in fairness to the vendors, these files were exported over a year ago. The schema was finalized very early in this year. And so that's some of what you're seeing here as well. In this particular file is an older version of the schema that was being used. And then some of the other checking that was running through was related to some late changes to data types for some of the elements of the alignment data. And so then another example here. Let's see. So then this is a newer file being generated from a different data set. And so just showing what this looks like for a file that processes and is valid. So you can see everything lighting up as green, or some of the items here that are shown in gray are items that aren't used or aren't present in this particular model, right? So especially now with our latest schema version of 4.3, including all these extensions for infrastructure, then you may have a model that is focused on roads and bridges and alignments and doesn't have any building information, or vice versa. And so that's what you'll see here in the validation service, where items that don't apply or rules that apply to things that aren't in your model are just highlighted as gray. And it shows that if you go in and expand some of those columns. Okay, I think I've got a couple of duplicates in here. We'll skip through this. Okay, so that's kind of again in the spirit of seeing is believing, a look into what that model validation process can look like. So now switching more into digital as-built, just as setting the stage here, a reminder that this is one of the more recent everyday counts initiatives from the Federal Highway. Again, as we can see here in our graphic, talking about the crawl, walk, run, fly process of as-built, starting from paper-based, moving into paperless, say maybe an image-based scan of a drawing, and then progressing into electronic document-based PDFs, and then ultimately kind of the aspirational goal here of an object-based model serving as a digital as-built. And so I'll talk through a specific project that's getting underway with digital as-builts formed around some of these same openBIM concepts. And so the particular use case here is focused on asset management and then load rating reference. So this is a demonstration project that was awarded a STIC grant earlier this year for bridge replacement in northeastern Iowa. You can see here way up in the northeastern tip of the state. And this is a truss bridge crossing the Mississippi River. And so HNTB is involved during the construction phase, which is underway currently. And during the design process, there was a 3D model developed in accordance with Iowa DOT's deliverables around 3D modeling and some of their standards and requirements and workflows that they've been building out. The focus of this digital as-built demonstration is primarily around document linking. And so we mentioned asset management or load rating reference. So the idea here is that once construction is finished and the bridge is in service, if we get 5 or 10 years down the road and we need to do an updated load rating for the bridge, or maybe do an analysis for a potential overweight permitted load, that there's a mechanism for efficiently retrieving all of the construction data. So not only the original design plans, but also all of the shop drawings and fabrication details, all of the material certifications, mill certs, test results, all of the things that you would want to know to be able to assess what is actually present and actually in service, so that you can then make an accurate load rating in this case. So some specific components of this demonstration project is that we're looking at a web-based interface and utilizing the 3D model as that user interface. So the idea being that if you're looking for information about a particular location in the truss, that you can go to the 3D model and click on those elements and then have that lead to links to the associated documentation. And again, the focus on openBIM in this case, so the latest IFC 4.3 data specification for the model. We're also lucky to have the opportunity to collaborate directly with the pooled fund BIM for Bridges and Structures team. So to talk through some of those work products like information delivery manual and some other outputs from that pooled fund study, again, to help make this a demonstration project of openBIM in action. I mentioned we're looking to link construction data and then also being able to locate and filter that information efficiently. So here is an example of what that can look like in terms of some very early work that we've been doing here. So this is our model here in our online platform, and this is an IFC. This is an IFC model that we've exported from the Bentley authoring platform. And we did this in multiple exports to reduce the file size and make things a little bit more efficient. And then we federated everything back together here within the viewer. So at this point, there are some early deliverables and early shop drawings that are filtering in. But for demonstration purposes for today, what we'll see is 3D elements in the model that are linked to their corresponding sheet or sheets from the construction documents from the bid plans. So no specific construction phase information data yet, but it is a good demonstration and a concept of really what we're talking about in terms of 3D model as a user interface to access the sheets. So we can see here we've clicked on the pier and we've got that highlighted. And then that's linked to our plan sheet here, giving us all the various details and dimensions of the pier. Then we can come back and do the same for the drilled shaft foundation. We see the link here as well, and can see that in a thumbnail or expanded out into a full view as well. And then moving into the truss superstructure, this particular node at the bottom of the truss. And so as you might suspect, because of all of the complexity of all these connections and gusset plates and bolts and everything that's happening, that there are multiple sheets associated here. So we can see that in this case, we've got 4 sheets and we can step through those and look at those. And again, get a quick thumbnail to confirm that it's what we want to look at, and then expand it out into a full size view if we'd like to. So yeah, again, just kind of stepping through this as a demonstration of what openBIM looks like for a real life bridge project here in the United States. And so then kind of the last example on the upper node of this truss. So this is document linking, and in this case, we're linking to plan sheets that are stored in a separate system, right? So kind of coming back to that concept of interoperability between systems, that if the model is in one location and the sheets need to be stored in a different location, that you can do that from a hyperlinking perspective and not necessarily need to have all of that data in one single repository. Yeah. And then as we zoom out here, you can see, again, we've got the bridge broken out into 4 different models here. They all start with the same name, so you maybe can't tell that. But yeah, again, providing some breakdown and being able to turn superstructure on and off compared to substructure and items like that. Okay, so we're getting close to the end here. I wanted to do a quick preemptive Q&A before we get into more Q&A, specifically around the question of how do we do quality control if the model is our legal document or deliverable, right? And this is a common question. And again, pointing to things that are common in industry now. This example here of what I think a lot of us are used to in terms of a record of a quality check having taken place, right? That we have our plan sheet with all of the highlighted information being checked as correct, and then some color coding comments and markups as things are revised that need to be corrected. And so, I think it's safe to say that most practitioners in industry are familiar with this, and I think it's also safe to say that if the plain sheets have been through this process, that most folks would be comfortable providing the corresponding electronic CAD files. But I guess the point here is that when you're doing that, if you're comfortable with the electronic data as part of that exchange, it's because you have done the quality check and the quality review of the representation of that data in the plan sheet. And so then as we move to model as legal deliverable or model as legal document, there's still the opportunity to do similar checks, even if the model is, I guess, primary in terms of the contractual source of the data. So what we'll show here is the fact that modern design and BIM modeling, when it's set up and utilized correctly, essentially there's no difference between the model and your plan sheets because your plans are being generated directly from the model. So in this example of our bridge project, we've got a number of different parameters here that we've set up to drive the geometry. And you can see as we adjust those, like if we adjust the span or if we adjust the skew, you can see the 3D model update here immediately in our view. And then if we spin over in isometric view, you can see those items updating as well. Right, so this is kind of our initial step in terms of doing our modeling. But the next step then in the project delivery process is to create the views of the model, the different slices or different views of the model that then become the various parts of our plan set. So then here, let's see, we'll reset some of these parameters back and then jump into what that looks like in terms of the plan sheets themselves. So again, we've got the same list of parameters that we're able to drive the model. And in this case, on this plan sheet, we even have an isometric view of the model. But we can see the same things when we update those parameters that the model, as well as the view of the model here in the plan sheet updates as well. And we can revert that back. And if we want to adjust skew angle, we can see that update. Now, in this particular example, you'll notice that the dimensions are static. And that's just because we've imported those as placekeepers from a static DWG file. But obviously within your authoring platform, you can set up all those dimensions to follow the geometry as necessary. So then here's another example, looking at the elevation of one of the abutments here. And so we'll change the wing wall length, the parameter for the wing wall length, and you'll see that update immediately in the sheet here as well. And then we also have parameters for the piling as well. So you'll see here in this demonstration, we'll adjust those next and see that update directly in the model. So I guess to tie a bow around all this discussion, if we focus on the model, have that as our primary focus during the delivery, then we can still create sheets. And I think there'll be quite a long period where we are still creating some number of sheets as part of our delivery process to go along with the model deliverable. But I guess the point is slicing your model and creating the sheets that we're used to and doing a quality control check of those sheets then becomes a de facto check of the model, right? So I guess boiling it down to a single sentence, if your plans are derived directly from the model, and you check the plans and you're happy with what's shown in the plans, then that then also becomes a check of the model data as well. Okay, so a couple of closing thoughts here, and we can open it up for some Q&A with the time we have left here. Obviously, this this whole concept of BIM and digital delivery is very disruptive. I think probably every bit as disruptive, if not more, as the transition from board drafting to utilizing computer-aided drafting. And I think we're seeing an overall increasing volume of information, an explosion of data, right? In even things that I hadn't really even talked about, like reality capture in LiDAR scanners and drones and photogrammetry, point cloud data, sensor data from all sorts of various measurements and things that we can attach to our infrastructure. But I think truly, if we look at the internet age, if that's the right term, right? Like everything about the internet and about our current digital lives is based on open standards. And so that's really, I firmly believe that's where things are headed as well in terms of infrastructure and openBIM for infrastructure. And I guess maybe my closing thought is that all these platforms and the vendors really should be competing solely on the merits and their features and their capabilities, and not so much on inertia or market capture. So with that, I'll pause and thank everybody that has stuck with me all the way to the end. If we have some questions either in the chat or if people want to unmute, we can talk through this.
Thanks very much, Scott. We do have a couple of questions in the question window, and let's see. They are both from Michael Lefontaine
Yeah.
and
Yeah, I can take these. So, hi, Michael. Thanks for joining.
okay, yeah, Michael, would you we can unmute your microphone or allow you to unmute it. Would you like to voice over these questions? They're really good questions about how the sheets are linked and whether or not they're useful in the field.
Yeah, sure thing.
Hey, thank you.
Great presentation. Thank you.
Thank you.
Yeah, so I noticed the linking the sheets to the model elements, that's tremendous value. So is that an automated process, or do you have to manually link those?
It can be. So full disclosure, what I put together for this demonstration was a manual process, but that will be an important early step in this demonstration project, is talking through how we can automate as much of that as possible. And what we have talked about with our construction team is that specifically for the truss, for all the members in the steel superstructure, all of their record keeping and information is based on the member naming, right? The the diagonals and the verticals and all those elements from node to node. And so because that's the naming convention that they're utilizing for all of their record keeping during construction, then the intent is to apply that same naming convention to the model elements. I think right now they all just have some generic names, but there's places that we can do that within the IFC standard. So the plan is to apply that naming convention to the model elements and then have that same naming convention as part of the documents, which would then allow us to do sort of a bulk attachment in an automated way versus someone having to manually connect those.
Yeah, that is fantastic. And I feel it's a great segue for the folks that, heavily rely on the PDFs, especially in the field and in the office. It allows them to start, getting familiar with the 3D model. It's excellent. And then I assume this is intended for field users. So when you're during construction, folks can, look at the 3D model and or the sheets in the field. Is that the intended use of this process here?
I would say that it's not the primary goal of what we're doing. So the demonstration project is more focused on of this as a digital as-built. So the use cases or the user stories that we've written are more of for an asset engineer or a load rating engineer that needs access to the data maybe 2 or 3 or 5 or 10 years down the road. But I think it would be safe to say that a nice ancillary benefit, a secondary benefit, is that, yeah, it absolutely could be useful during construction, exactly for the reasons that you say, right? Helping to make the connection between the 2D sheets and construction plans and what folks are seeing in the 3D model. And yeah, even on a day-to-day basis, right? If an inspector is if the inspector is down in the cofferdam while the drilled shafts are being constructed, and they have access to the model and know that they can just navigate to that and click on it to get to the associated plan sheets or specifications or whatever. Yeah, that certainly could be a really valuable use of these types of tools.
Thanks, Scott. Doing excellent work.
Yeah, thank you.
Okay, we also have a question from Pavel. Pavel, would you like to voice over that question? Which has to do with asking if there's a tool for creating IDS.
Yes, first, many thanks for interesting presentation. And we actually use for the validation some add-on for Trimble Connect, and next we would like create some inputs dialog connect to BSDD, and I test many for them for ACA software for BuildXMart itself. For me, it's very interesting what you prefer, because in the end I prefer wrote this IDS schema directly in a notepad. Yeah.
I'm not sure I understand the question, but I think at least in terms of tools to be able to generate the specification,
Yeah.
there's multiple options out there. To be honest, I haven't really used a whole lot of them because I tend to be more of a text-based developer type of person. The work that I've done has gone directly into creating the IDS manually in the text editor. But I think actually I think some of the earlier webinars in this series earlier this year have demonstrated some tooling and some products that can develop those IDS specifications, and even doing IDS in the context of the whole BIM process, right? Like BIM execution planning and requirements, and then the IDS that can be used to check and enforce those requirements. So,
okay.
Yeah.
Many things. I have the same. For me is actually quicker make this code directly for Notepad. So
Thank you.
Okay, we have a hand up from, I'm sorry, I'm not going to pronounce the name right, Chiamba.
Yes, good morning, good afternoon. Can you hear me, please?
Yes,
Yes.
we hear you very well.
Okay, thank you. I have a question about the specification delivery information. My question is if you specify the information and we can use a different tool, and if the tool they are not certificate to use the kind of information, and they deliver out that information, how we proceed to check the information that we specify?
So both the model information would need to be exchanged in IFC format, and then the specification for checking would need to be developed and exchanged via the IDS specification, and then the output from those checks in terms of how it's formatted and how you would report that. That I think tends to vary from tool to tool or product, a particular product that you would use, both in terms of what the default output would be, as well as your level of ability to customize or adjust or add specific columns or pieces of information.
Okay, thank you.
Thank you.
And also, James Halba offered us, if we want a little more information on the bridge project.
Yeah, I really don't have that much. Now, the little history on that bridge is the 2D plan sheets were the legal contract document, and we created the model after that part was complete. And then we put a stick grant together, and after seeing what Scott presented today, I'm really looking forward to this continuing. I guess I'll ask a couple questions though, since I am talking. how do you see the national standards helping adoption? You know, you got the BIM for Bridge Pooled
Yes.
Fund, there's BIM for Infrastructure proceeding, and I know BIM for Bridge is very focused on open, standard, non-proprietary, and delivered the design to construction workflow.
Yeah.
And my other question is, I'll get two of them in at the same time. Usually I'd run 3 or 4. So how do you see context capture? You know, there's a lot of softwares now. You create content that's industry standard. And there's a lot of them that can actually start doing feature extraction, crack quantification, honeycombing. There's even one that does automated deck soundings now on the bottom side and in the vertical, which I found very interesting. How do you roll that back into an asset management program? I guess I kind of have my ideas on that. And to me is, you know, we need to use that model and bring it forward to that level to be able to tie these, but I'm not sure on the LiDAR and the context capture and that stuff. There, I'll let you answer now and I'll quit talking.
All right. Well, yeah, thanks for that, and thanks for helping me with some additional context on the example. So the first part, the value that I see for these national efforts in the pooled fund studies is that it helps us to standardize at maybe a higher level, right? So currently, a lot of, I'll say in current state with 2D delivery and development, almost all of the requirements and specifications tend to be unique per state or per agency. And I think the efforts happening at the national level with the pooled fund studies are helping to drive consensus for what information is really important, what information or how it needs to be represented most efficiently and effectively. But I think primarily making a standard that can apply as much as possible across the board nationally, right? So thinking of it as a practitioner and as a consultant, it's much easier to be successful in BIM for digital delivery if the majority of those requirements are consistent across the board nationwide. And maybe, I don't know if we just want to throw some numbers out, like say maybe 80% of what we need in our model is kind of defined at the national level, as opposed to maybe 20% that is state specific or agency specific. So I think in my mind, that's one of the primary benefits, but certainly not the only benefits of that ongoing work. And I guess also certainly the focus in the work around all of those requirements, focusing on openBIM and open workflows as well, for some of the reasons I had said around software inclusivity and vendor neutral formats. So then in terms of the context capture and the LiDAR scanning and all of that amazing work that is happening, I think ideally I would like to see, or I would hope to see, that information can be captured and can be exchanged in a similar way to what we're talking about for the BIM data, that being an open published standard that allows for the same flexibility in terms of tools doing analysis or viewing or incorporating it into asset management systems. I think there's maybe, from what I can tell or what I see, a bigger gap between what's currently happening in that arena and standards or maybe lack thereof around consistent ways to exchange that information and exchange those findings. But I guess my goal or my hope would be that as much as possible that we can find ways collectively and collaboratively to coerce that information, if that's the right term, coerce it into some of these open formats that then can come into that central IFC data model that we were talking about, and then allow for all these various different systems to be able to read and push and pull from.
Thanks, Scott. We really appreciate your staying a little overtime. If you've got a little bit more time, Richard Bryce has a question. It's something of a follow-on, asking about generating model from LiDAR. And Richard, we've opened your mic so you can actually voice over that more eloquently than I.
Yeah, Scott, thanks for the great presentation. This is actually kind of a follow-on to what Jim was asking. It's most of our infrastructure is existing.
Yes.
So to get this benefit of the BIM models and stuff going forward, somehow we have to get our history into this new digital realm.
Yep.
So
Yep.
Can you speak to kind of what's going on? I mean, what comes to mind for me is, you know, generating some rough models from LiDAR and somehow maybe using AI or something to link that stuff up to our existing PDFs of scanned plans that came from, you know, vellums and blueprints or whatever it may be.
Yes.
So,
Yeah, absolutely. Excellent point, right? You're exactly right that, you know, a lot of what we've talked about is BIM modeling and information for new projects or rehabilitation projects, but doesn't immediately address the tens of thousands of existing assets that are in place. So I guess I'll take the LiDAR scanning scan to BIM question first. What we have seen as the most effective the most effective process in that arena is to actually build a model from the record drawings first, and then use the LiDAR to calibrate it, if that's the right term. Obviously, that only works when you have those scanned as-builts ahead of time. But yeah, I think, like you had said, the general case is that a lot of that information is available. So at least in our experience, what we've seen is building a BIM model from the as-builts first, and then referencing the point cloud, and then adjusting the geometry in the model to match the reality of what was actually constructed based on what you've measured from the point cloud. That's what we have seen as the best process and the best approach. And then in terms of all of our PDFs and scanned images and that we currently have, turning those into BIM models, I think is certainly achievable in the not too distant future, based on some of the AI tools that are available. Even and maybe not so much some of the more recent generational AI and large language models, but maybe some of the more, I guess, at this point, traditional, right? They were cutting edge 2 or 3 or 4 years ago, but things move so quickly, they're not right on the tip of the cutting edge. But things like object detection and computer vision and some other terminology that I'm forgetting. But yeah, I think the opportunity is around building out automation and potentially utilizing deep neural networks and such to be able to recognize the information that's in our record plans and record scans of PDFs, and build models from that as the initial starting point to populate our inventory, and then as time or as budget allows to go and do the reality capture and LiDAR scanning, then to verify the geometry of what's been extracted from the PDF plans. The beauty in that process is that the level of detail generally that you need for asset management is not the same level of detail that you would need for like design to construction or design to fabrication, right? So again, kind of the 80-20 rule, that if you can get the primary bits of information about your assets, right? Like your span configuration and skew and number of beams and types of beams and so on. If you can extract all that information in a reasonably automated manner, then that gets you pretty far down the road of getting to a full digital as-built or digital twin of the entire system.
Thanks, Scott. VP Vignesh has 2 questions, one about SUE and IFC, and another about visualization platforms And VP, if you'd like, you can unmute your microphone and elaborate the question. Okay, maybe, oh, there we go. Yep.
Yeah, thanks for your nice presentation, Scott. Yeah, so my question is, like
Thank
you
you.
mentioned about SUE and IFC,
Mhm.
like other digital delivery, platforms.
Mhm.
So could you please elaborate some of the use cases? Because for the most of the utilities lines, it will be like we'll be having existing records like PDF or else
Mhm.
CAD files or else hard
Mhm.
copies most of the time.
Yep.
So
Yep.
is it possible to convert them into openBIM data so that we can integrate with existing or else the new upcoming data?
Yeah, good question. What we on this particular project that I used as the example, a lot of times we are adding additional property sets to refer back to as-built record plans, like PDFs. So, for example, when we are updating a existing utility model based off of an as-built drawing that we have, then we'll add the the project name, project identifier, the rough date as best as we can in terms of when that asset was constructed, and then even a page number as well. And in this case, the PDF files typically are multiple sheets. Now you could do some of the document linking similar to what we had demonstrated graphically for the bridge. If that's if a link back to the record drawings is the primary the primary link or the primary documentation that you would like to see in terms of what you're interacting with in a subsurface utility model. And then generally, again, what we have been doing on that same project, if there are CAD files, DWGs or DGNs or DXFs, usually we will utilize those to directly update the geometry of that asset in the model. So then once we've done that, the discrete DWG doesn't need to be maintained or linked to the data because the information in that drawing has already been incorporated into the model. So, but yeah, ultimately, ultimately the goal is to try to be able to explain to a downstream user what level of confidence they can put into what they're seeing into a model, right? Because it's not really cost effective to go and expose every single utility, right? You can't necessarily pothole everywhere, same way that you can't really do a geotechnical soil boring everywhere. So what we're talking about there in terms of the quality levels really is trying to help like someone that's designing a new project that's in the area, and there may be some utility conflicts that if they do a preliminary layout and they see, okay, here in 2D, it looks like we might have a conflict, but based on where this designed element is going to be relative to where the existing element is going to be, then it looks like we're okay. But then maybe they go into the model and there isn't any additional metadata pointing to an as-built drawing, and there isn't any other metadata other to say that this is quality level D, then that would be a trigger and part of the planning to say, oh, okay, we really don't have super reliable information for this particular asset, and so this is one that would be a good candidate for some potholing or some additional research, be that physical or more on the electronic side to look for more record drawings and as-builts.
Yeah, that's great. Thank you. And there is one more question actually. So you talked about web-based, visualization platforms to view the model models to sheets or whatever it may be, and we can comment there too. So, but if anything needs to be changed in the model or else if we need to edit them, again we have to rely on the native format or else the software which we use to produce the model. So, how to overcome this challenge and achieve complete open BIM,
Yeah, so for that specifically, I think that's where we get into things like the application programming interfaces or the APIs that allow that would allow a native authoring platform to be able to connect to an IFC model that's in a common data environment, to read the information and allow the users to make the edit in that user interface. And then at least initially, that information is in the native format of that particular tool. But then once the update is changed and it's ready to be published back to the common data environment, then the API between the environment and between the native tool can then convert back to IFC, so that it's rather than a wholesale back and forth, that it's more of incremental object-based updates. So I think, to be fair, that particular workflow is probably more aspirational and future looking than what maybe is currently possible. But that, at least from my perspective, is the desired end goal or desired end state.
Oh, that's great. Thank you.
Thank you.
Thanks, Scott. We have one last question, we promise.
Yeah.
It's from
Yep.
Rand Robinson, and it's a really interesting question about control of the model throughout the project life cycle. Rand, would you like to voice that over yourself?
Yeah, can you hear me?
We got you.
Yeah, the question, this comes up quite a bit in our discussions at work, is, who is going to control this model? And my logic or reasoning is this: you have a design model that you've stamped and sealed somehow, whatever the methodology, or even if you have it's irrelevant. But nowadays in construction, we build off plans, we build off cross sections in a highway type thing, and we don't really care what happens in between the two sections, say on a sheet, and we also know that in construction, a large majority of things get changed or moved for convenience. We didn't design the intersection exactly right, or the light poles in the wrong spot, so on and so forth, and it's easy to move. Problem with the model, though, is when you start to make changes like that, it can change the whole model, for hundreds of feet, possibly, changing a quick cut or fill slope to make something fit within a right-of-way line or something, could propagate through a whole model. Okay, now that changes the whole design that somebody else worked through. So the question is, who is going to be in control of the model? Or does it even really matter? Because, I could technically see a design model being delivered. Okay, now that's going to be turned into an as-built model, which could be totally different than what was designed, so to speak. Within certain reason. And then that model needs to be pushed downstream for a true digital delivery system, so that it goes into maintenance and they can grab whatever pieces they want or take out pieces, or even later on, remove pipes or put in a new, So who do you see as you move through this as control, or do you see that it's going to have to be a huge trust issue within the organ, particularly like a DOT, because, we're an owner, builder, blah, blah, blah. And in a design build situation, it's easy to see who would control the whole thing. But in a design, bid, build, maintenance situation, that becomes pretty blurry, at least. Do you have any thoughts on that?
Well, first of all, great question. And certainly not a solved issue, at least at this point in time. I guess my initial thought for an answer would be it depends, right? And I know that's squirrely. I think so. A couple of things. And again, what we have started to see is generally there's a bit of an air gap, if that's the right term, from the design models and the as constructed or as built models. And so what we have started to see on some of the projects is a workflow where the design models are pushed across to the contractor, and then we refer to those as the design intent models, right? And then as the work progresses, the work is installed, and then it's surveyed or measured, and then that is the basis of the as-built model. And then you have the process of reviewing those two things together. Say, okay, this is what the designers intended. This is what actually ended up in the field. And if there's difference, like exactly like you mentioned, there's a lot of times very valid reasons for that. That is at least one of the things that I've started to see is a little bit of a like I said, kind of an air gap or a separate model of, okay, this is what the designers had from their design intent. This is what actually ended up, and then working through if there's anything that needs further discussion, or maybe strayed too far in terms of maybe what am I trying to say here?
Yeah,
But,
I mean,
yeah,
in some
yeah.
cases, there's little design things where people fix things,
Yeah.
and there could be major design
Yeah.
things that were negotiated here, there, or the other
Yep.
thing by the contractor. But you also have that issue of, state says the owner, we have a contractor who doesn't like the model, doesn't trust the model, does their own
Yeah.
model,
Yeah.
puts it in their machinery, blah, blah, blah. And, there's always this set of plans, this paper set of plans, unfortunately, which is what we're trying to get rid of, that you can always go back to and say, well, we didn't do this and do this. And then you can present that at a court of law, or you can present that for payment,
Yeah.
that kind of stuff. But with a model, you're generating, theoretically, you should be generating plans and stuff on the fly.
Yep.
You should be doing that. So now, who's actually in control should the owner be modeling as the contractor goes, which is technically possible, or do you have the contractor modeling and, the plan, the original intent, original model is in a box somewhere. I mean, just how do you, and I guess how do you see that going? Because it's very theoretical right now. I mean, we're not doing any of this stuff right now. But it always seems to gum up the works as we discuss this and try to move forward to grab each little bit.
Right.
And I'm just curious on how everybody else sees that.
Yeah. Okay. Yeah, you're right. It is it's complex. I think what I would maybe see as the ideal scenario is that the as-built model is primarily built from data collection as opposed to authoring, and that measurement, that surveying or collecting of the as-built state, I think could be done by the owner or by the contractor, right? As long as the people doing that are qualified in terms of surveying a final graded surface or a ditch profile, or you name it, whatever. The other thing I think that I see as helping with helping with the question of the complexity of who owns the model. If we start to think about it less in terms of huge, great, big, complex models, and think about it more as discrete objects and discrete parts, then it helps make those updates happen more quickly, because they're smaller, both in terms of model size and amount of geometry. And I'll give a for instance here. So some of the work that we're talking through with one of our DOT clients is specifically around miscellaneous assets. So we have a dozen or so assets like storm sewer pipes and inlets and manholes, and guardrail and signs and so on. And ultimately, they know that the desire is that asset inventory is going to land in GIS. It starts out as part of a design and then is handed over during construction. So part of the potential workflow is to be able to capture that asset information as part of the design deliverable, make it available to the inspection staff and resident engineer and so on that's on site within mobile device. And then as that work is happening, they can measure and confirm that, okay, yeah, this inlet went in per plan, it's good to go, and it's been completed and it's been accepted. And then maybe the next inlet needed to move a couple of feet because of whatever reason, and so the inspector updates that geometry and then potentially adds additional information in terms of maybe specific material information, or can provide a date for when it's installed. And so then in that manner, the model is being updated on an almost continuous basis, and it's very discrete, like individual types of items. And so you're building the as-built model or the as-built inventory as you go, right? Based on the amount of work that's done in any given day or week. But yeah, I think it will depend on specifically what parts of the model we're talking about, right? As well, right? Like a surface model that covers a great big area is very different from like a storm sewer model that might just have a couple of inlets and manholes and pipes in a very small contained area. And like a roadway corridor model that might stretch for a couple of miles. Right? Are you managing all of that as one single model and one single piece, or is there the ability maybe to segment that out, and again kind of make smaller incremental updates to the model along the way based on surveyed information, maybe that's happening daily or weekly or even monthly.
Scott, thank you so much. We really appreciate the fantastic content in this presentation, and just noting it is the first time in Building Smart USA history that a 1-hour webinar has gone to over an hour and a half because there was so much participation from those who were tuned in. So thank you very much. We'll process this recording. We'll make it available on YouTube. Scott will share with you some of the many kudos that have come in while you've been doing the presentation. Thank you very much. Thank you to everyone who dialed in today, who participated. The questions were really insightful, and we appreciate your probing this topic more deeply. We'll post to YouTube so that you can share with your friends. Thanks, everybody. Have
Wonderful. Yeah, thank you. Thanks, everybody. Have a good rest of your day.